Okay, let's get started here with section 3, dividing polynomials. Now, we talked briefly in section 1 about dividing polynomials, but we kept the examples. Well, actually, we were just dividing monomials. So this section, we're dividing polynomials, which means multiple monomials hooked together with addition and subtraction. Before we start that, we're going to go all the way back to dividing with dividing numbers using long division. Okay, so if I want to take 192 divided by 17, this is what that would look like. I would put the 192 under the division sign here. So 192 divided by 17. And what I would do is I would take 17 and I'd ask myself, okay, well, how many times does 17 go into 1? Well, it doesn't, 0. So then you go to the next number and say, all right, well, how many times does 17 go into 19? Well, 1 time. You can get one, there's one factor. No, that's not right. There's one, one multiple of 17 that will go into 19. So 1 times 17 is 17, and then you subtract. So subtract, you get 2. And then you will bring down the next number, which is 2. So you get 22. And then you say, all right, well, how many times does 17 go into 22? Again, one multiple of 17 fits into 22. So 1 times 17 is 17. You subtract. And you get 5. And that's your remainder. So there was a couple ways that you could write your answer. You could write remainder of 5, just like that. Excuse me. Another way was, and the way that actually turns it into your answer into a number, was you would write 11 plus the remainder, 5, over the divisor, 17. So 11 plus 5 over 17. And when you do that, you get just 11 and 5/17. Okay, so that's how long division worked. Do the division, get your remainder, and then write your answer as your dividend here, 11, plus remainder over divisor. Remainder over divisor. Might even be worth writing that down. Remainder over divisor. Okay. For polynomials, the process is the same. Okay. And we will learn a different type of division called synthetic division in a second, but for polynomials, we can do this long division, and it's called polynomial long division. So let me show you how that works. We're going to take x cubed minus x squared plus 4x minus 10 divided by x plus 2. So this will look like this. The x plus 2 that we're dividing by will go outside of the division symbol. Then we'll have x cubed minus x squared plus 4x minus 10. And then we'll go from there. So I'm going to take x plus 2, and then I'm going to ask myself, how many times does x, this leading term, go into x cubed? Or what do I multiply x by to get x cubed? That's a better way to phrase it. What do I multiply x by to get x cubed? It's x squared. Now, just like when I didn't show this out explicitly, but over here when I said 1 at first, I could have taken 1 times 1, which is 1, and then 1 times 7, which is 7, to get 17 here. I'm going to do the same thing over here. I'm going to take x squared times x, that's x cubed. X squared times 2 is 2x squared. So it's going to be plus 2x squared. Now, I'm going to subtract. Okay, so remember that you're subtracting up here. I'll show you a different way to do this in a second, but for right now, let's just try to remember that we're subtracting. X cubed minus x cubed is 0. That's what we wanted. Negative x squared minus 2x squared is going to be negative 3x squared. Bring down the 4x. Ask myself, what do I multiply x by to get negative 3x squared? It's negative 3x. And then I'm going to multiply everything by negative 3x. So negative 3x times x is negative 3x squared. Negative 3x times 2 is minus 6x. And then I'm going to subtract. Negative 3x squared minus 3x squared. Minus a negative is going to be 0, so those are gone. 4x minus a negative 6, that's plus 6. So it's going to be 10x. Bring down the negative 10. Sorry, I did not leave a lot of space here. What do I multiply x by to give me 10x? Well, that's going to be 10. 10 times x is 10x. 10 times 2 is 20, so plus 20. Subtract. These go away. Negative 10 minus 20 is negative 30. So my remainder is negative 30. Okay, but my answer is going to be written in this form that I did over here, remainder over divisor. So my final answer, I don't have room to write it very nicely in the box. I apologize for that. I should have planned better. But my answer is going to be x squared minus 3x plus 10 plus remainder over divisor. So plus the remainder, which was negative 30, divided by the divisor, which was x plus 2. Okay, so negative 30 over x plus 2. And that's how long division works. Okay, you should go ahead and try number 3. Pause the video here, and then I will show you the solution as in just a second. Okay, so let's look at number 3 then. Hopefully you paused and gave it a try. We're going to take 2x minus 3, and we're going to divide that into 2x cubed plus 5x squared minus 2x minus 15. Okay, so I'm going to ask myself, what do I multiply 2x by to give me 2x cubed? That's going to be just x squared. So x squared times 2x is 2x cubed. X squared times negative 3 is minus 3x squared. And then I'm going to subtract. So I'll have 2x cubed minus 2x cubed, that's 0. 5, and it's really easy to forget that you're subtracting here, so be careful. 5 minus a negative 3 is plus 3, so I've got 8x squared here. Bring down the negative 2x. And then ask myself again, what do I multiply 2x by to give myself 8x squared? That's 4x, so plus 4x. 4x times 2x is 8x squared. 4x times negative 3 is minus 12x. Subtract, these are gone. Negative 2 minus negative 12 is plus 12, so that's 10x. Bring down negative 15. And then what do I multiply 2x by to give me 10x? That's going to be 5. 5 times 2x is 10x. 5 times negative 3 is minus 15. Minus 10 minus 10 is 0. Negative 15 minus a negative 15, that's plus 15, is 0. So I get a remainder of 0. So my final answer then for this expression, when I do the division, is x squared plus 4x plus 5. That is, if you graph this thing and you graph this thing, you will get the same graph. They are the same graph, okay? Okay, now, the instructions on this one are to use synthetic division. Synthetic division is different. It's completely different, but it's much faster. The thing with synthetic division is that it only works when your terms that you're dividing by, the divisor, is in the format of x plus a or x minus a, all right? So this one, we could not have done synthetic division, 2x minus 3, we would have been stuck with long division, okay? So this one, though, we're taking 2x cubed plus x squared minus ax plus 5, dividing by x plus 3. So we can use synthetic division. Here's the process. Make a little box, okay? What goes in the box? Well, it is the opposite of whatever sign is in the divisor. So if it's plus 3, then negative 3 goes here. Okay? Across the top row, we're going to put all of the coefficients, and we have to make sure that all of the powers are accounted for. And this is true for long division too, but it wasn't an issue before in the problems that I gave you. But I need to make sure that if I start at x cubed, that I have x cubed accounted for, x squared, x to the 1, and this is actually x to the 0, but we never write it there, okay? All those need to be accounted for. And we are going to write the coefficients out. So the coefficient on x cubed is 2, 1 on x squared, negative 8 on x, and then 5 is the last number there, okay? You're going to bring down the 2, and then you're going to multiply. You're going to take negative 3 times 2, which is negative 6. Then you're going to add. 1 plus negative 6 is negative 5. Then you're going to multiply again. Negative 3 times negative 5, positive 15. Add them up. Negative 8 plus 15 is going to be 7. Then you're going to take negative 3 times 7. That's negative 21. Add them up. It's negative 16. Then you're going to write out your answer. This right here is your remainder. Imagine that was a good R. So that's your remainder right there. Excuse me. And then your final answer is going to be decreased by 1 degree from whatever you started off with. So if you started off dividing into a cubic, a third power, then your answer is going to be a quadratic. It's going to be to the second power. So your answer here will be 2x squared minus 5x plus 7 plus remainder over divisor. So negative 16 divided by x plus 3. So it's a very weird process, but it is much faster. And the more you practice it, obviously, the better you'll get at it. And so you will take, but that is your answer. All right, so let's do a couple more of those just so you can, or at least one more so you can see the process again, okay? So my divisor is in the format of x plus b here. So I'm going to take and make a little half a square, negative 2, and write the coefficients out. Now here I have fourth power but no third power, and I have no first power either, first power term. So I'm going to write 3, 0 in place of that third power coefficient, negative 4, and then 0 in place of that 1 power coefficient, and negative 16. All right, now we're going to take and divide. So I'm going to bring down the 3. Negative 2 times 3 is negative 6. Add them up. 0 plus negative 6 is negative 6. Negative 2 times negative 6 is positive 12. Add them up, I get positive 8. Negative 2 times 8 is negative 16. Add them up, I get negative 16. And then negative 2 times negative 16 is positive 32. Add them up, I get positive 16 for my remainder. So if it started off as a fourth power polynomial, when I divide once, it'll be down to a third power polynomial. So my final answer is 3x cubed minus 6x squared plus 8x minus 16 plus 16 over x plus 2. Okay, I think we'll call that good for part 1 of this lesson. Part 2, we will knock out 6 and 7.